So today we're looking at proving figures are congruent. So we're trying to do this with rigid motion, meaning that all of those figures are going to be exactly the same when they're moved. They're not going to change in size. And what I've got here is I've got a graph with three different figures on it. And I want to know if triangle DEF is congruent with triangle ABC, and I want to know if GHI is congruent with ABC. Now there's a couple of ways we can go about doing this. We can go to the good old patty paper, where what we're going to do is we're going to trace that image and find a way if we can get it to actually move, translate to another spot. So when I move it over, it appears, and it's a little hard to see on camera, so I'm going to make it darker, it appears just a little off when we look at the DEF triangle. And when I go looking for the GHI, we appear to be pretty on. Now, a tracing paper is one way to check measurements. Another way we might check measurements is I might choose a side like CB and set my protractor to that distance. That means that one of these has to have the exact same distance as DEF. When I look at that circle, and I'm going to darken it up for you, when I look at that circle, I see that it is just off. There's that tiny bit of space. So it would appear that they are not congruent. But if I look at DE or GHI and I go looking, I'm looking at a short side, it appears that it's not. Now, if you go look at my measurements, you see that I messed up drawing the graph. And so for me, that's not the biggest deal. I don't tend to rely on the image being in the correct dimensions. I take it for the measurements that are there. What I want to do to be absolutely sure that these are the same is I want to apply a distance formula. The distance formula is going to make life very easy for me, because what it's going to do is it's going to allow me the opportunity to really just check measurements very directly. So what I'm going to do is I'm going to go checking a single side. I'm going to see that side BC, and using a distance formula is equal to the square root of, I have a 4 and a 9 minus a 6, and then there's a 7. So 4 minus 6, that's 2, squared is 4. 9 minus 7 is 2, squared is 4. That's odd. It would seem that I've oops, that's why. Okay, so we have a plus. Ooh, wrote it backwards, really messed myself up. So 4 plus 4 and a square root. I'm just going to call BC equal to the square root of 8, or I could call it 2 square root of 2, simplified. So what I'm doing is I'm thinking about the short sides here, and I'm going to look at DF. DF is equal to the square root of 13 minus 16 plus the square root of 4 minus 5 all squared. So 13 minus 16, that's a negative 3, squared is a 9, plus there's a negative 1, squared is a 1. So DF is equal to the square root of 10. Now these are the short sides compared to the short sides. Since these are not congruent, I know that this right here is not a congruent figure. But let's look over here. Let's look to the short side here. Let's look at GI. So from G to I, applying that same distance formula, what I get is 4 minus 6. 4 minus 6 is negative 2, squared is a 4, plus negative 2 minus a negative 4. Negative 2 minus a negative 4 is 2, and squared is 4. So this is the square root of 8 or 2 square root of 2. So GI is congruent with BC. These are the sides that match up. So I have GI, BC. Now what I need to do is I need to check AB. AB is equal to the square root of 1 minus 4 squared plus 5 minus 9 squared. So we have negative 3 or a 9 plus 4, a negative 4, which is 16. The square 9 plus 16, that's going to be the square root of 25, which is 5. So AB is 5. Now, knowing that this is 5, what I need to do is figure out which side here is going to be the same. Is it HI or is it HG? I'm trying to think about that negative 3 difference here. So if I'm moving in my x's and I need to see a 3, it would be nice, but I don't see it. I see going from a 2 to a 4, 2 to a 6. So I'm going to go ahead and just try HG. And HG is the square root of 2 minus 4 squared plus negative 7 minus a negative 2 squared. So there's negative 2, and that's a 4, plus, well, that's a positive 2, negative 5 squared, that's a 25. So HG is equal to the square root of 29. So HG is definitely a different measurement. Let's check AC. AC is equal to the square root of 1 minus 6 squared plus 5 minus 7 squared. So 1 minus 6 is 5, squared is 25, plus, well, that's a negative 2 squared is a 4. So AC is equal to the square root of 29. So the good news here is AC and HG are the same. So AC I'll mark with 3, HG is marked with 3. Let's confirm that HI has the same measurement as AB. We've already done the AB. AB is 5. So what I'm going to do is I'm going to try HI is equal to the square root of 2 minus 6 squared plus the square root of negative 7 minus a negative 4 squared. So 2 minus 6 is negative 4, that's a 16. Negative 7 minus a negative 4, that's a negative 3, squared is a 9. So this is now going to be equal to the square root of 25, which is 5. So HI and AB are both the same, and I can see by using the distance formula that the ABC triangle is congruent with the GHI triangle, but they are not congruent with the DEF. There's quick, easy methods which are great for ruling things out, but you really do want to fall back to the algebraic and calculate it and verify that figures are congruent and they do have rigid motion. What you could do next is you could figure out exactly what the translation is to go from the XY to a new XY. If this video has been helpful, please like or share. And if you have any questions or comments, they go below.